Hello and welcome to today's European SharePoint Office 365 and Azure Community webinar. My name is Orla and I'm delighted to be joined by Mihai from Avaelgo, Romania, who will be talking to you today about migrating enterprise applications to Azure Cloud Native. Remember to join in the conversation about today's webinar on Twitter. Our Twitter handle is @EuropeanSP and our hashtag is ESPC22. Don't forget to check out the Resource Centre. This is updated daily with the latest blogs, ebooks, webinars, and how-to videos. Simply visit sharepointeurope.com and click the content link at the top. A big thank you to our sponsors, Docs42 and Pointfire. It's great to have their support.
Hey you! In the session you will see all about the great options of the Microsoft technologies. But what about generating documents in the Microsoft ecosystem? Like quotes, reports, emails, PowerPoints, and others. The challenges usually are many different data sources, an intuitive design in Microsoft Office, and of course, generating the documents where the user needs them. In SharePoint, the Power Platform, Teams, or Dynamics. Docs42 can do all of it. Try now yourself.
Hi, I'm Martin from Pointfire. This year I was hoping to entice you with a booth, games, prizes, giveaways. Instead, we have this short video to show you how we make the multilingual page publishing feature even better. It's so easy, the demo only takes a few seconds.
With SharePoint's new feature, your staff still has to translate each page manually. By adding the Pointfire translator, the pages get translated automatically for your approval. Go to try.pointfire.com for a free trial or contact us for a demo.
Continue your Azure learning by booking the European Power Platform Conference tutorial, How to Extend Power Platform Using Azure Services with Vishwas Lele. Find out more at sharepointeurope.com/European Power Platform Conference. Call for speakers is now open for ESPC22. Submit to speak at sharepointeurope.com/submit-speak-ESPC. After the webinar, there will be a questions and answers session. Type any question you have in the questions window. Questions will be selected and answered at the end of the presentation. This webinar will be recorded and added to the Resource Centre, where you'll be notified by email when it's available. And now I'm going to pass you over to the presenter, Mihai Tataran. Hello, Mihai.
Thanks everyone for coming. My name is Mihai, and during the next 45 to 50 minutes, let's say, I want to take you through some considerations regarding migrating apps, let's call them enterprise applications, to Azure, and especially to what cloud native and what the modern techniques and technologies are. I work for a company called Avaelgo. This is the company that I started 15.5 years ago, where we're mostly specialized on Microsoft technologies. We do a lot of projects around the Microsoft Cloud, so Azure, but not only, and some AI projects. Now, if, let's say, until 2-3 years ago, our main projects around Azure were to migrate existing infrastructure, VMs or workloads, how they were, into Azure. Now we're focusing more and more into transforming applications, re-architecting them, basically, or including rewriting parts of those applications so they fit better into Azure. That's what we do, and this session is based on this experience. This is what we're going to do in the next years, even more than we're doing today. My background is of a software engineer. So I started my company immediately after university, but I do write code from time to time. I don't in production environments too much, but I'm a software engineer who has a lot of experience on Azure. Many projects I worked in, especially so initially as a software engineer, but then as a consultant or architect or whatever you wanna call that. Some objectives with these workshops are to understand how to start thinking about how to migrate applications into Azure, right? First, understand the big differences from the architecture standpoint, and also to understand some relevant principles and frameworks on how to do that. We're going to touch Cloud Adoption Framework and well-architected framework, which are some methodologies given to us by Microsoft based on their and their partners, now I would say very good experience of migrating applications to Azure. It's been years, so there are a lot of patterns and practices and good experiences. So they have all been grouped into those frameworks. That's what we use, by the way, in our day-to-day job in my company, and I find them extremely useful. But I will start with why. Why move an application to Azure? And I'm pretty sure that everyone we encounter has a different answer, slightly different answer, but I find some patterns in our customers. Our typical customers are large to very large enterprises, so companies with thousands or tens of thousands of employees, and sometimes a bit smaller, but usually in that range. So they kind of have the same reason. So first of all, it might be cheaper, and I say it might be cheaper. You have to be very careful about that. It's always a trap if you just look at Azure as a larger data center, and if you want to compare the cost per month of a virtual machine with the cost for the same kind of virtual machine on premises. So that's not the good way to look at Azure. It might be more expensive if you just treat it as a larger data center. So if you start using more services, if you go towards more platform as a service functionality, and especially if you use the out-of-the-box services that it offers, it will be much cheaper, especially for very large workloads. Related to that, not only the direct cost of using the resources, but also your man hours, your operational cost will go down. Or maybe let's rephrase it, your IT cost, if you move your applications to Azure, will not go down, but with the same team, the same amount of man hours, you'll be able to do much more. So it's just another way to look at that. A very interesting thing as a motivation to go towards Azure is for ISVs, so companies which have their own software written by themselves, into what means gaining bigger markets, access to a much larger number of clients. So if you're an ISV which is developing their own software and you're installing that software into the customer's environment, you have a few problems. First of all, you might encounter performance or scaling issues with your software, which runs into the customer's environment, right? So it's very hard for an ISV to maintain the infrastructure underneath the software that's installed in the customer's environment. So it's very, and I'm referring to the second point here on the slide. It's very hard to offer the best performance, the best scaling for your solution when it's installed in a customer's infrastructure, especially because you don't have access to it. You cannot configure it, you cannot design it. So from that perspective, installing your own software into your own Azure subscription makes much better sense because you control the infrastructure. So you're able to serve more complex or bigger customers, with larger databases, larger scaling needs, and so on. Another aspect would be sometimes these software products have some dependencies. For example, they need a SQL Server. The license cost for small customers could be too high a barrier. And if you just forget about installing the software on their own premises with their own SQL Server, which they need to buy, and just rent it out as a subscription from Azure, gives you access to a larger number of smaller customers. Another reason to move to Azure is access to modern technology. And here I would quote whatever serverless is, all those things around the serverless idea, analytics and AI. it's very hard to implement your own machine learning, your own big data analytics tool on premises. It's much easier, if not the only way possible, to use a public cloud provider to do that. So that's a big reason sometimes. Then, kind of related to that, faster time to market, especially if you design or redesign the application to be more cloud native. To think about organizing it into microservices instead of layers or tiers. And those microservices, in the end, give you the possibility to develop different sets of functionality of your whole application independently. So you're able to ship them independently. You don't need to wait for the entire development team, to be on par, to have a shippable product. You can slice your software into value streams, into sets of functionalities which are independent. Of course, if you design it properly, like a microservices model. But it gives you, with using the right technology, it gives you the faster time to market that we all need. Of course, security and trust. I mean, a public cloud provider is usually much better prepared to fight cyber attacks than we are on our own. And of course, higher availability, better disaster recovery mechanisms. So this, in a nutshell, would be some of the reasons that we've seen of our customers to move their applications to Azure, and we're assisting them, of course. Now, one of the biggest lessons that I've learned in the last 2 years, 3 years, I would say, is that depending on those reasons, of those initial reasons of moving the workloads or the applications to Azure, the consequence is that the way you do the migration is very different. So let's jump into that. First of all, let's consider a few things that we need to think about. Number one is a methodology. Is there a set of methodologies or a set of principles that we can refer to when migrating existing applications into Azure or existing workloads, whatever that they might be? And the answer is yes, and we're going to dive into that right now. It's called Cloud Adoption Framework. Now, this is a much larger framework than what you need to move an application. It's designed for moving everything to Azure, right? You can imagine it as the framework to help you move your entire organization to Azure. But of course, it's helpful when thinking about migrating workloads or independent applications as well. Now, just as a brief comment here, we don't have the time to go into details with the Cloud Adoption Framework, but I do need to point out that these 4 stages that you see here, defining the strategy, do the plan, do the readiness, and then start adopting, which is migrate and other things related to that. So the series of the steps makes a lot of sense. And I'm going to refer back to what I just said a minute ago, which is our customers might have very different reasons to move into Azure, their application. And that's why we have this stage over here, to understand the motivations, to understand the justification and the outcomes. So it's one way or one thing for a customer of ours or for a company like yourselves to have the reason to move out of a data center because your contract is expiring, or you have to renew your hardware. You're at the end of the cycle. So that's and there are many other examples like that. I would call them, reactive reasons. You have to react. You have to get out of your on-premises or your data center or whatever you might have, and move into Azure, into a public cloud, as soon as possible. If you have that kind of justification, then probably you're not inclined to redesign your application, to re-architect it. You just want to move into Azure as soon as possible and be operational there. On the other hand, the other extreme would be, well, I don't necessarily have an event I need to react to. I can take my time, but when I get into Azure, I need to be very efficient. So to best use the technology that I have in Azure, platform as a service, off-the-shelf functionalities, and also prepare for the future. Like I need to be very scalable, auto-scalable. I need to be able to use technologies like machine learning and AI well integrated into my application, and so on and so forth. You know, excellence in operations, automation, alerts, dashboards, all that stuff. And you know, when you have that kind of need, of course, you're gonna be more inclined to go into the whole redesign and the whole work you need to do to better use Azure. Now, this kind of reasons comes from I need to be more effective, more efficient, stuff like that, as opposed to the first kind of reasons, which is I need to react to something very fast. So that's what the methodology suggests. Go through the definition, understand why, and then start planning. And by planning, we mean, well, understand if we need to get some new skills, to define the team who's going to do that, the team who's going to operate the application once it's in Azure, alignment inside the organization around how do I purchase Azure? Do we already have Azure? If we don't, we need to have a new contract. If we do, then okay, we start thinking about governance because we have some things in Azure. We're bringing new stuff in Azure as well. So all that thing that needs to be considered. And then you go to the readiness, which is again depending on where the organization is at that point when you're moving the application. Do I already have things in Azure? Do I already have an Azure Active Directory set up? Do I have the structure of subscriptions with all the policies assigned, with all the role-based access control? So what kind of users, what kind of groups are doing what? One of the things that we always find is usually our customer, they call us after it's burning. In this particular case, they call us after they moved an application to Azure. Let's say it's a critical workload for them. It's something, line of business, but which I know is very important for the business for some reason. And things are not going well. Sometimes they tell us, well, it's not working as well as before, performance-wise. It doesn't scale. Users are complaining all the time. It fails from time to time. Or that's a bunch of reasons. Another bunch of reasons would be around the cost. It goes well. I mean, the application performs very well. The users are happy, but my costs are through the roof. Or security-wise, I have no idea who can do anything in Azure around my application. And that's because usually they just moved the application to Azure, made sure that it worked, and never thought about the governance. Things like who should have the access to the Azure resources supporting my application? Do I need to scale? What is the disaster recovery plan? How about security? So all those things need to be planned, at least with the version 1.0 MVP kind of readiness into the governance. So that has to be done before we move the application. Otherwise, it's going to be very costly. And after we have that, for example, I know exactly in which subscriptions my application will reside. And I said plural, right? Meaning I should probably have a subscription for non-production environments. I should have another subscription for the production environment or environments if I have more. And probably they are on two different hierarchies in terms of how the subscriptions are grouped into management groups, and probably having different policies and different kind of groups, user groups, with different kind of authorization attached to them. So all those things need to be thought before moving the application into the cloud. Even if it's the application that we use internally, or we're an ISV and this application is used by multiple customers. So in both scenarios, I would say. Good. So depending on the kind of need that we have, reacting to a very, soon event, a very, an event which is coming very quickly, or I need to be more efficient, more, using more newer technology. And assuming that we went through the steps of, planning and readiness, then we go to the actual migration of the application. And very high level, we have multiple ways to do that. So from an on-premises deployment, which is probably, let's particularize it to .NET application, .NET framework, multi-tier, and layer, whatever you want to call it. The quickest way to do the migration is to just do a rehost. And that responds very well to that scenario when I need to move fast out of the data center, right? I just kind of copy the virtual machines from on-premises to Azure, exactly the same topology, exactly the same infrastructure architecture, and it will be, running within days, most probably. Or I do a kind of migration which implies using platform as a service functionality in Azure, which could be containers or other things like application web apps, for example, in Azure. In this particular case, I could do it without big impact in the architecture. I simply containerize my application and put it into containers, and it will work. In this case, I'm a bit more optimized, meaning I don't need to take care of virtual machines. I'm in a kind of a platform as a service functionality. It could be web apps, it could be containers running on, I don't know, AKS or other things. We're gonna discuss briefly later on about the technology choices that we have. But for now, let's say we are in a platform as a service kind of architecture, meaning we don't have to maintain virtual machines. So my cost is going down. I have less things to think about. I just need to manage my app and my data. And of course, there's the whole modernization, which is re-architect, right? Re-architecting my solution, my application, not only to be able to fit into Azure, which is kind of easy to do, as you just saw, but I redesign it so it's a cloud native. It's a modern application, meaning microservices, meaning serverless. Now, that implies re-architecting. That implies a lot of work. That gives me the best efficiency, the best set of, modern cloud, let's say, benefits that I can imagine. Things like faster time to market, because I'm in a microservices architecture, so I can develop functionalities very independently. I can develop faster. I can deploy into production faster independently by microservice. I'm much more reliable. It's more resilient, the solution itself, because even if I have a problem with one microservice, all the others don't fail. It's cheaper because I use serverless technology instead of pre-allocated machines. So I have a lot of benefits. And of course, it's the most expensive transition. So it's always a matter of balancing out what I need to do, what I want to do. There are many ways to modernize. A very simple diagram here explaining I am on premises and I don't go full cloud native. I just use platform as a service functionality. So I'm somewhere in between with this migration. I still need to do some changes because some of the code needs to change. If, for example, I replace a middleware section with a Windows service running on MSMQ with web jobs and queues in Azure, parts of my code need to change. Yes, I'm going to be much more efficient using platform as a service functionality, as you can see here, as opposed to just using virtual machines, but I need to do some work before I do the migration. That was just an example. Other things to consider when we do the migration, so besides the methodology, Of course, some operational things will change. Your CI/CD will have to change. Your monitoring and instrumentation need to change. We're going to touch on those points later on. Just wanted to briefly mention them. Now, from the architectural point of view, here we have a list, and this is not a full list of things that we need to consider before we migrate the application, no matter how we do the migration. We do a rehost, we do some modernization so it fits into platform as a service, or we do a full re-architecture so it goes into cloud native. Doesn't really matter. I have to ask myself these questions, and we're going to go into more detail around some of them, but I want to touch base on the others right now just a bit. So for example, let me choose lock-in. From an architectural standpoint, from a design standpoint, I need to think about, okay, I move my application to Azure. What if 5 years or 3 years from now, Azure becomes so expensive that I want to get out of Azure? How locked in I am. Now, the general rule of thumb would be the more I start using platform as a service components, the more locked in with the specific cloud provider I have. So it's one thing to just rehost and use virtual machines and install my software there. And it's a quite different thing to use web apps, Azure web apps with Azure storage, with Azure Active Directory, right? The more functionality I use, the more locked in I am. Now, that's the general rule of thumb. And there are very good exceptions coming in or happening already in the recent years. One of them would be when you use containers and you use technology like Kubernetes. AKS would be the Azure version of Kubernetes, which is 100% compliant with the open source Kubernetes, then you're less locked into Azure. It's containers, it's Kubernetes, basically. Yes, you do have some degree of lock-inness, if you want, if you start using specific things around AKS, which are specific to Azure, I mean. So just, orchestrating those containers, running them, allocating pods on nodes, that's standard. What's not standard is the way which, for example, Azure uses to create virtual nodes or to auto-scale, to have elasticity around virtual nodes. That's non-standard. The same thing with Azure Functions, to give you another example, right? Azure Functions don't depend on Azure to run. Their engine, the engine which runs the Azure Functions, is just a container. So when you write your Azure function, you can test it locally on your dev machine. You can deploy it into Azure, or you can deploy it anywhere on a Linux machine or in another cloud provider because it's a container. So there is a very much smaller degree of dependency to Azure or with Azure if you use Azure Functions that it used to be years ago. But again, the same principle. When you start using very specific functionality, very Azure specific functionality, then of course you're more tied into Azure. And the more enterprise your application is, chances are the more such functionality you will use. For example, durable functions. It's something specific to Azure. So if you just take that container and you put it into another host, you don't have the concept of durable functions. So just to give you some examples. Now let me dig into some of those a bit more. So when you migrate your application to Azure, you need to think about the topology and if it changes, especially if you're doing something else than just rehosting, right? In this particular example, this hand drawn diagram, I took an application from on-premises, which was a web app with a SQL server, SQL database sitting on one machine, and moved to platform as a service into web app and a SQL database, respectively. Now, in the initial state, the communication was done between these two layers on the same machine. In this end state, the communication is done via another channel. So the whole topology changed, which in some particular cases where my application would be or was because it's a real scenario, was very chatty, I had a lot of performance penalty. So I need to change the code, right? From entity framework lazy loading to eager loading. That's just a particular solution that we found in this particular case. But the point here is many of the legacy or old enough applications have been designed with this, subconscious consideration that, all the layers are very grouped together. You have the application, you have the server, you have the backend, all of them are in the same office or on the same machine. And if you move it into Azure, let's say if you move it completely to Azure, let's not even consider the hybrid situation when you move it partially. Let's say you move it completely to Azure, but you start, putting layers on different services in Azure, then you change the topology. And chances are some of those parts of those applications have been written to be very chatty, because the developers back then, 10, 15 years ago, didn't have the notion of time, of penalty. All those calls were on the same machine, and that changes probably. Another thing which changes is the nature of the environment we sit in. So when we use things like SQL database as a service or Azure storage, those functionalities are provided to us by Azure from a distributed environment and a multi-tenant environment. So our database sits on the same machines with other customers' database. Our Azure storage, the same. It might happen that we encounter transient faults. So the environment is temporarily unavailable because maybe another customer has driven the CPU on that particular machine to 100%. And we might be affected. So the way you design the application for Azure is to expect transient faults when you use things like Azure Storage, SQL Database, and so on. And there are ways to do that. It's called transient fault application block, handling application block. There are multiple ways to do that, but we have to consider such things. Latency. Of course, the cloud is not quite near us. It's a bit further away. So we need to consider things like, especially if we do a hybrid scenario, we have a desktop on premises and the server side in the cloud. And there are ways to do that, to decrease the latency. Of course, Traffic Manager, which is like a DNS load balancer, which allows us to serve our user from an endpoint which is closest to them. Of course, this way we need to deploy in multiple Azure regions. Azure Front Door Service, which is a service which allows us to expose our functionality through the Microsoft backbone closer to our user. So our user would input www.myapplication.com. They're very, very far away from the Azure region where the application is coming from, but the application is being delivered through the front door service, like in a CDN environment, like in a CDN infrastructure. So there's a proxy much closer to our user. And when they hit our FQDN, they're actually redirected through the Microsoft backbone to the actual Azure region which is serving it. Virtual One, the same, except it's not for web applications, it's not for layer 7 traffic, but for TCP traffic. And many, many other considerations. I'm going to skip through some of them. The point here is, or the major question is, how do I see the cloud? I should see it as not only a larger data center, but a bunch of newer functionality or functionalities that I need to onboard, right? Otherwise, it's going to be more painful, more costly. There are some relevant design patterns, which I'm going to mention briefly. When we redesign for the cloud, retry pattern is the pattern for transient faults that I just mentioned a few minutes ago. Competing consumers, just a basic publisher subscriber design pattern, where in the center of it we have Azure queues. Think about an online shop, users browsing through the front end, and there's a backend service processing the orders, and then we have the queues leveling out the load. Priority queues, a very interesting kind of pattern, which kind of derives from the previous one. This one is very relevant, especially if we design a multi-tenant environment or a multi-tenant solution. So think about it. Let's say you're an ISV and you design your solution for multiple customers. Some of your customers have different needs, performance and scaling needs, than your other customers. You have your premium customers and your basic customers. How do you serve them without, doing different deployments, multiple deployments for types of customers? Where one of the solutions would be to prioritize the requests coming from more advanced customers through a specific queue to multiple consumers, multiple backend services processing those requests. That's what we understand by priority queue. Another interesting pattern, which is an alternative to scaling or auto scaling, which is one of the reasons to use Azure, right? But this is an alternative. So auto scaling is great until you hit the maximum budget, right? And you don't want to go further than that. So what do you do then? One way to treat that problem is you simply reduce or temporarily reduce functionality. You simply, I'll give you a very stupid and simple example. You hide the button, you hide the menu item. Of course, you can do it more nicely from the user standpoint, but you constantly monitor some metrics, some performance metrics around your Azure infrastructure. And when they hit a point, a threshold, you simply deactivate some of the functionalities in your application. So this is a very nice pattern, not very used. People don't think about it, but it's very useful. There are others, but not specific to Azure. I won't spend too much time. Let's talk about technologies that we have in Azure and how to choose between them. So yes, we briefly mentioned Cloud Adoption Framework and the methodology, which is depending on why I move to Azure, I have multiple ways to do it: rehosting, doing platform as a service, optimization, or complete re-architecture, right? That's from the methodology standpoint, because I need to understand what I need to do. But now let's talk the same thing or the same kind of thought process, but now from the technology standpoint. Now, in terms of cloud native, just to give a very brief definition if you want, these are applications in modern dynamic environments, such as public clouds, which run on immutable infrastructure, which are loosely coupled, resilient, manageable, and observable. That's what cloud native stands for, right? Now, if we talk about designing or redesigning our application for Azure, let's say the vast majority of the applications can be categorized in one of these scenarios. It's either an N-tier application or a publisher subscriber web queue worker, or microservices, or CQRS, or event-driven, big data, and big compute. Most of the modern applications can be, well, maybe there are exceptions, which I haven't mentioned here, right? But Usually those are exceptions. And the question is, if I know what kind of application I have, what are the technologies? And is there a formal approach to tell me what kind of Azure technology to use? And the answer is yes. There are multiple sources of information, but one of them is the architectural guide for doing technology choice. And there's a decision tree. I put the URL here because it's changing over time, right? As Microsoft ships out new functionality, this particular tree will change. So this is the newest version. I think it's from November 21, right? So quite new, I would say. So let's say when we want to migrate an application to Azure, right? If my reason is I want to get out of a data center, I need to move fast. So if I choose lift and shift, yes. Can it be containerized? No, let's say. Then I go to either virtual machines or Azure App Service. If it can be containerized, then I go to the right-hand side of the tree. Or if the first question here was answered by, yeah, I can optimize it. I have the time, or the reason for doing the whole migration is not because I want to get out of the data center, but because I need much better, efficiency, or I want to be able to use better technology. So I want to optimize for the cloud. Then I have a bunch of other questions. Is it a high performance computing workload? If yes, then go to Azure Batch. If no, is it a microservices architecture? If no, then go to just pure platform as a service, Azure App Service. If yes, then as you can see here, all these options here are a good option for microservices architectures. And I would argue that there's a new piece of functionality which is not present in this chart. I'll explain it later. But coming back to our question, is it a microservices architecture? Yes. Is it mostly event-driven and short-lived? Then Azure Functions would be the way to go. Now, as a personal side note, I've been working with Azure Functions since they have appeared in the first place. They were like a very nice thing. You would run very isolated things, and they have evolved to a true enterprise serverless public cloud solution. I mean, it's amazing what we can do with Azure Functions, right? Really, you can manage state, you can orchestrate multiple functions together in like a series of, like, imagine workflows. It's very complex. Let's say our system is not event driven. Do we need we don't need full-fledged orchestration, but orchestration in this case means we mean orchestrating our workload. If it fails, it needs to be able to restart on its own. It needs to be able to auto-scale and so on and so forth. If it doesn't, then Azure Container Instances is the simplest way to go. So I would argue that if we have a simple microservices, but not very important from the business standpoint application, then it's very simple for us to use Azure Container Instances. If it's an enterprise application, then we need orchestration. We need some tools which are able to, as I mentioned, monitor, give me some alerts, restart processes if necessary, etc., etc. So I need orchestration. Do I need a managed service? If no, then I can simply do some kind of containerized technology, but in infrastructure as a service. If I need a managed service, and if I already answered yes to these questions up to this point, I probably want to go further with the same kind of approach, which is I do need managed services. Then I have a bunch of options in Azure, which I love. I mean, they are very, very different. One of them is Azure Service Fabric, and you might be familiar with it. It's Microsoft's internal solution or technology for microservices. It's what they use for their own functionality. And it has been exposed to us, and it's useful if I have an older .NET, meaning not .NET Core, and probably N layer, N tier application. I would argue still against using Service Fabric either way, because it's very hard to do operations. It's not robust. I wouldn't call it a robust technology. But let's say it's a modern application that we have in mind. And we have extremely nice and interesting solutions here, like Azure Spring Cloud, which is Spring Framework as a first-class citizen into Azure. And actually, we're using this right now with one of our customers because they have written microservices in Java using the Spring Framework. And now in Azure, we have a platform as a service functionality which sits on top of AKS, but which allows you to look at that thing not as a bunch of nodes, but as a framework where you deploy your Spring microservices. And that's quite amazing, I would say. On the same level, I would mention it's called Azure Container Service, I think. It's a new stuff which appeared a few months ago, which is Microsoft's platform as a service functionality on top of AKS. Okay. Similarly, I don't personally have use cases for Azure Red Hat OpenShift, but we have OpenShift as a service in Azure, which is amazing. And of course, last but not least, we have AKS, which is a containerized solution as a service. I would call it harder to use than Azure Spring Cloud or Azure Container Service, which again is not present in the diagram, because you need to consider, you need to kind of know things around your network topology, your IP range, how many IPs, fixed IPs you need to have, and so on and so forth. But yet again, this is a very good starting point for what kind of technology options I have and what choices and how do I make those choices. Now, last but not least, and we have like 2 or 3 minutes and then I'll switch to questions, is let's say we migrated the applications to Azure, or we thought thoroughly about how to do the actual migration. We know the technology, we know where it will sit in Azure. We need to think about how to operate it. And that's why we have well-architected framework, which is a framework, a bunch of principles, which are aiming to help us better run or operate our application in Azure. And because we don't have the time in 1 hour to spend, to go into all the details, I just want you to have a bird's eye view, which is what are the 5 pillars of well-architected framework. And they are, I would say, viewing correctly and then optimizing the costs. And here we have multiple options like role-based access control, so who does what, but also Azure policies and Azure budgets. So there are a bunch of technologies and functions in Azure that we can use. The second pillar is operational excellence. And here I would mention monitoring, Azure dashboards. I would mention log analytics. I would mention runbooks, so automation. I would mention ARM, infrastructure as code, stuff like that. Performance efficiency, of course, performance itself, but also scaling. And I would mention auto scaling or designing your own scaling mechanisms. Thank God we have lots of functionalities, which are, for example, we have metrics coming from the Azure infrastructure and how it runs, and we have alerts, and we can automate based on those alerts to change our infrastructure. So we have lots of ways to be able to scale automatically. The next one is reliability, which is designing for higher uptime, for better uptime, and designing our disaster recovery mechanisms. We have lots of functionalities over here. And last but not least, security. And here would be, let's say, a breakdown of what each of those means. And of course, we always have to keep in mind that we have to do trade-offs. Depending on the environment that we're looking at, is it a non-production environment? Then, of course, maybe the best or the most important pillar is cost. I don't care about performance or scaling, or I don't care about automation that much. It's a dev environment, as opposed to mission critical workloads where I have to be much more careful around security, around automation, around scaling, and so on and so forth. So this would be, in a nutshell, what we call well-architected framework. And actually, it's a very useful framework. Whenever we, in my company, I mean, when we help somebody migrate an application to Azure, this is one of the things that we use all the time, because it puts you into perspective. It forces you to answer questions now before the migration, questions which are regarding how will I operate. But if you don't do it now, it would be much more costly further down the line. Okay, that's what I had in mind in terms of content. And we still have some time for questions.
Thanks, Mihai. So if anybody has a question, you can type it into the question box now. There's none there so far. Great webinar, thank you. Few comments coming in to say that thank you very much. Great webinar, thanks. No questions, Mihai, you must have done a very good job. Thanks very much for everything, Mihai. Thanks for taking the time.
Thank you, Orla.
No problem.
Thanks, everyone.
This is the end of today's webinar. Thanks very much. Take care and goodbye.
Thank you. Bye-bye.
Thank you.